Hi there, my name is Hannah and I am a food educator with Common Threads Farm, and today I am so excited to have you here with me because we are going to explore the stuff that's right below our feet. Now, it's not the floor of the headquarters here. No, today we're talking about soil. And soil is one of my favorite things to talk about. When you look at soil, it can tell us so much about our environment. It's like reading a geological journal when we explore it. So I'm so excited that you're here with me today. Soil is a mixture of a lot of different things. It'd be easy just to call it dirt, but that's too simple. Soil is a mixture of broken down rocks, plant matter, living organisms, water, and air. It's kind of like we're making cookies and gotta put everything in the batter, right? On average, 50% of soil is made up of minerals. Minerals are like the building blocks of soil. Powerful forces like wind and rain and time wear down rocks into those individual minerals, and eventually they become part of the soil. Now, let's talk about how we go from really large rocks to the little particles that make up our soil. This happens through a process called weathering and erosion. Now, first, looking at weathering, have you ever left a drink in the freezer or maybe outside and it's frozen and maybe it's even exploded? A really similar thing happens with rocks. If we have a large rock, I never said I was an artist, and let's say it has a small crack. Over time, some water will find its way in there, fill it up, and when it gets cold enough outside, that water is going to freeze, and during that freezing process, it is going to expand and deepen that crack in the rock. And over time, when that keeps happening, this large rock will get broken apart over and over and over again until it creates those smaller pieces that make up our soil. Another way that we have weathering out in the world is through the powerful force of wind. Now, it might seem between a battle between a rock, a really big cliffside, and the wind, my bets are on the rock. But if you give it enough time, wind is a powerful enough force that when it travels over this cliffside, it's slowly going to break little pieces off of it. And when we're talking geological time, it is a really long time. This isn't happening in days or weeks, but those days and weeks add up, and we get our little particles of soil. So that's our weathering. The other force that we are working with here is erosion. So when we're looking at erosion, I gotta check my spelling sometimes, I'm pretty sure that's right. When we're talking about erosion, let's say we have a river, and this river is flowing, and in that river we have lots of different rocks, and because of the flow of the water, they're bouncing around, and they're knocking into each other, they're knocking into the side, they're getting smoothed over by that water, and that water is slowly working away at those particles. And that's how we get things like sandy banks of rivers. So erosion and weathering are our two main forces when we're talking about how we go from really big rocks or even small rocks into those tiny particles that make up our soil. Now that we've learned a little bit about weathering and erosion, we're going to learn more about the 4 different types of soil. They are loam, sand, silt, and clay. And we're going to explore some soil samples together and learn kind of where those soils come from and are found and how that interacts with the world. So I'm going to pass it off to my colleagues in the field, and we're going to go pick up some soil samples.
Thanks, Hannah. Hi, everyone. I'm Gabe, and I'm here at Waypoint Park, and I'm here to collect some sand. So we've got all sorts of rocks around here, but we have this small patch of sand amongst them. When I feel the sand, it feels kind of gritty. It feels pretty, feels rough. It's a little moist, probably from the recent rain that we've had. And it's filled with rocks, kind of the rocks around the area. So I'm gonna take a quick sample. Let's go back to Hannah to learn a little bit more about what makes sand, sand.
Thank you, Gabe. As Gabe mentioned, sand has that kind of gritty texture, and that's because it is the largest particle that we are talking about today, so we can really feel the size of it. Sand is the largest particle because it's the most recently broken down from rocks, and because of its larger shape and the space in between the individual particles, it's a lot more easy for the water to flow through, so it has really good drainage. And it's most commonly found in areas like the beach. Back to you.
Let's hear from Katie at the creek.
Thanks, Gabe. Hi, my name's Katie and I am here today at Maritime Heritage Park to collect some samples of silt and hopefully some clay as well. As you can see behind me, along with our audience members, the geese, we can see Washington Creek streaming through and creating a beautiful area for us to take a soil sample of some silt today. So as we can see, if we look at this soil, it's definitely pretty wet from the river and probably from the recent rain. But we can see that it's pretty slidey. It's pretty like slippery and slimy. So I think that Hannah can tell us a little bit more about that. To you, Hannah.
Thank you, Katie. As she mentioned, silt has kind of a smoother consistency and touch than our sand, and that's because those particles, as you can see, are quite a bit smaller and closer together. This means it has that smoother texture, and it's a little bit harder for water to get through. And now silt is often found on riverbeds with a companion particle that's a little bit harder to find, and that is our clay. Now, clay is the smallest particle we're going to talk about today, and that's why it's a little bit harder to find. The clay particles are super small, and they all like to be really close to each other. You know, they like to give each other little hugs all day, very close. And because of that, it is really hard for water to move through clay. It takes a long time. And clay is one of those cool ones too that we see out in the environment, but we also see it in our day-to-day lives. Certain types of clay are often used to create things like coffee mugs and different kinds of pottery. So there's lots of cool ways that our environment engages in our day-to-day life as well. So I'm going to send it back to the field where we are going to explore a really special kind of dirt that utilizes a lot of the different things we've learned about today. All right, back to you guys.
Thanks, Hannah. Now I'm gonna pass this over to Maddie so she can talk a little bit about loam.
Thanks, Katie. It's Maddie here, reporting live from the Wagka Middle School Hoop House. And today I'm going to talk about loam, which is the type of soil that we use most commonly in our garden beds. Now, feeling the loam right now, it feels nice and fluffy, and this type of soil is great for our plants to grow. And I'm going to pass it back over to Hannah, who will tell you more about loam.
Thanks, Maddie. So now we're going to talk about loam, which, as Maddie mentioned, is a super awesome soil that we often find in our gardens. Just like the garden you might have at school. Now, loam is made up of all the different particles we've talked about today, plus some super awesome organic matter. So when we're looking at loam, it's typically 40% sand, which remember is our largest particles here, about 40% silt, which is our ones, just a little step down, and about 20% clay, which is our smallest particles. And then we have humus, which is our organic material, making this perfect kind of smoothie of soil. It's all the great mixtures that we love to see. And one of the reasons that farmers and gardeners love loam is because of the permeability of the soil. So when we've been talking about how water moves through soil today, that is this concept called permeability, and that means how easily or how hard it is for water to pass through our soil. So for sand, it's very permeable because water flows through it really easily. For clay, it's a lot harder because of those smaller particles. So when we have our loam, which is a mixture of all three of those, it's permeable enough for water to move through, but then because of that clay, some of that water is retained, so it's allowed to stay in the soil and not go all the way through, so that the plants can access all the minerals that they need from that water. So that is a little overview of our loam in our gardens. Now let's go to the lab and see more about these different soil types.
He's off to the lab. Hi, it's Gabe again. Welcome to the lab. Today we're going to do some soil tests and learn a little bit about what a hypothesis is. These soil tests are important because they can help us figure out what our soil is composed of. I have some of our samples from earlier today, and I also have a mystery sample, which will be the basis for my hypothesis. So, before we get started, I think we're going to have a little bit of a change of scenery. My main goal today is to learn more about my mystery soil. In order to learn more, I'm going to start with a hypothesis. So a hypothesis is a tentative explanation for an observation, phenomenon, or scientific problem that can be tested by further investigation. In other words, it's a tool that we can use to test our best guesses on why something occurs. So a question that I'd like to answer is, what particles make up my soil? My hypothesis, based on what background information I have on where I found the mystery soil, leads me to think that it might be similar to the loam sample that we took from the Wacom garden today. My working hypothesis is going to be that the mystery sample is probably made of mostly sand and silt, based on the fact that loam is mostly contains sand and silt. So that's going to be my working hypothesis. The first test that I'm going to be doing is the touch test. So using my fingers, I'm going to examine the soil texture and see how it feels, kind of similar to what we were doing earlier today. I'll be using the texture by feel analysis worksheet to walk myself through figuring out what kind of soil I have. The very first step is going to be to add a little bit of water to break down this soil. You'll know it's ready to go when you can mold it in your hands. Make sure to take your time as you're going through the worksheet, going step by step, and writing down your observations as you progress through it. In my case, as I was trying to do it, I realized quickly that, for whatever reason, it was very hard to figure out what kind of soil type it was, which made me even more interested to see what would happen in our next test. Our next test is the shake and settle test. To begin, we'll take an empty, clear container and fill it a quarter full with the sample. Next, we'll add water until the container is almost full. The final step is to shake the container vigorously for 1 to 2 minutes. Make sure the lid is fully on before doing that. Then we're going to put it down and wait for the contents to settle. I let mine settle for about 5 minutes. Throughout this process, use the reference sheet to help determine what the layers represent. If I zoom in on our samples from today, you can see a tiny layer of clay forming. For my mystery soil, I discovered that a lot of it ended up floating. When I researched this further, I discovered that my soil most likely came from a bag of potting soil. What you see floating is organic matter, in this case, peat moss. The more you know. Even though my hypothesis turned out to be wrong, I'm happy that I learned something new. A hypothesis guides us, but should not define our result. So, I wish you all the best in your own investigations, and we'll catch you next time. Thanks for watching.